Hi guys, I'm Shandeep Singh and I'm part of Team Rockstar.
Hi, my name is Casey Reyes. I'm a software engineer, and I'm basically working on the software side of this whole project.
I'm CY Wong. I'm working on this project. I've mainly focused on the IoT connection, the hardware side, and database management.
Hi, my name is Neil Guerra, and I'm working on the Lambda function that are creating logic in the application.
Hi, we are Team Rockstar, and our project is the Rockstar traffic light. So the problem is that the current traffic control is managed by weight sensors, and sensors aren't always precise. For example, traffic lights can't read how many cars are waiting at a traffic light. Also, some major cities operate on timer-based traffic lights, and vehicles remain idle.
So our proposed solution is a smart traffic light system, which detects vehicles on the road. And it's better because current traffic systems cannot detect how many vehicles are on the road and only can tell you if a vehicle is present or not. Additionally, our system will be able to detect what type of vehicles, such as bikes, trucks, or a simple vehicle is present on the road. And we can use all this information, upload it to our database system, and use the data to produce an efficient and a productive product that will help alleviate traffic issues.
Okay, so this is the brief box diagram of our project. So I will briefly explain how the whole process will go. First, we use a local PC, and then with a graphic card, and then using the YOLO object recognition software to process the image. And then the software is slightly modified, and then it will return the number of cars per of each image, and then we will simply use it, run it every 10 seconds, so we can get an estimated traffic flow per 10 seconds. And then we use the MQTT and connection and upload the data in JSON format to the IoT, AWS IoT, and then the AWS IoT will trigger the rules and then push the data into the DynamoDB. Also, the DynamoDB will set up another trigger to trigger the couple lambda function, and then by reading the lambda function, by reading the data from the database, it will decide which traffic light should goes to green or which traffic light should goes to red, and then send back the stop or go signal to the traffic light using the MQTT again.
Previously, Jay discussed the overview of the whole application, and I'll just be going in depth on how our logic is set up. So our Lambda functions take data from each of the camera points, and the cameras are directioned going north, east, south, and west. And we'll be taking the data and checking how much traffic flow is going towards that direction. So as you can see, if a car comes right, multiple cars stop on the west side going towards east, we have a count of 40 cars, and there's only around 20 car count on north to south side. We'll be prioritizing, the Lambda function will be prioritizing east to west side first, and we will send that data back to our traffic system using the MQTT protocol.
Okay, so we can start the demo of the IoT device right now. I will show you how the YOLO will upload the data to the AWS IoT. And then first of all, we have a data file that saves tons of photos that of many from the web, and then it's like fake data for us to test. Okay, and then we start running our program, and then currently it's loading the weight and then start to process the data. And I have set up the subscriber to the topic on the AWS IoT, so if there's any message coming, and then you will see here. So the current time is 6:45, and then we've just got the a new message coming from the IoT device. And then we can go to the DynamoDB to see, because we already set the rules, and then any new message will push directly to this database. Okay, so I think 645 is these two. Sorry, I forgot to query the data, so it will be a little bit messy, but here is it. And then we also have a trigger to trigger the different lambda function, and then we also create a second global index, so we can do the sorting much effectively for our lambda function. Okay, we first of all we create a structure of data structure like in JSON format, and then this will be the message that push to the IoT AWS IoT, and then these are all using the AWS APIs to make the AWS connection. For example, here AWS IoT clients, and then configuration, the endpoint, set the endpoint, and then put all the certificates, private key, and to them. And this is our main function. So first of all, we just connect to the AWS, and then run the YOLO function, detect, and it returns the how many cars in that picture, and then we can push it to the IoT using the publish function. Okay, now we are trying to simulate getting subscribed to a topic on the AWS IoT, and then when the lambda function completes the calculation, they will send an email, a message to our traffic light device. So right now we're sending the 1 to our IoT device, which turn it to red. Sorry, turn it to green, and then we can try on sending 2 to make it turn to red. Okay, and then back to 1, from red to green. Here we go.
Jay talked about our IoT device, which was a local PC, and he showed how to utilize the YOLO system to process an image and use the processed image data and the MTT protocol to publish to our DynamoDB database. So let's move on and discuss how we're going to process that data using Lambda functions. So we have 2 Lambda functions, traffic control and traffic control 2. And traffic control read or writes to the database in case we need a change of event. For example, to change the color of the light system, we need to specify if there are certain amount of cars coming towards our route or not. So here we have an example, and we will be writing to the traffic flow data table, and we have set the status to true. So we want the light color to change. So we use that parameter and the location and how many cars were counted and the time. And let's test it. Okay, now let's go check our database and see if there's any entry that was made to that. Okay. Okay, as you can see, our time, our location, the flow, or how many cars were on that intersection at the time, and the status. So Jay will use this information to interact with the hardware. And let's go back and try out our other function. And this function reads from the database. So in case we need to just test functionalities, we will utilize this Lambda function. So that was our previous entry, and we will use the time as our main primary key to check. And let's test out this Lambda function. As you can see, it gives back how many cars, what time, and location. And this will further help us just connect and create the application.